Hi there, so in this video we're going to look at all the little sneaky 1 or 2 mark questions that they put in the National 5 exams that are based on your knowledge of trig graphs. Now some of these haven't come up at National 5 but they used to come up at the Old Credit and Intermediate 2 papers, but they are sneaky and they really do test you a bit, so these would be the level A style questions just to get your marks up a wee bit. So everything you're going to see here has been used in the past. And it all comes from your knowledge of these 2 graphs. So in an exam, I would recommend that you're able to draw these graphs from memory. And they're not actually as bad as you think. You just have to remember that the sine and cosine graph both go from 1 to -1 unless there's a number in front of the equation. The sine graph is this lovely S shape. And then it's all using symmetry. If you remember, it finishes at 360. You've got 180 in the middle. And then in the middle again, you've got your 90 and your 270. So you just have to remember the 360, half it and half it. And then the cos graph is the lovely kind of big valley shape or the C shape. I think I've seen it actually being drawn as a hammock with a wee person kind of lying in it. So remembering that it's a wee cosy hammock. So again, it finishes at 360. You've got 180 in the middle. And then you get the 90 and the 270 for finishing again. Now the period of both of these graphs, remember they start to repeat and go again. So the period of each of these graphs is 360, okay? And then you might not have heard the words mentioned too much yet, or you might, depending if you've done quadratics. This bit here at the top of the sine graph is called a maximum turning point, and the lower bit is called the minimum turning point. And a wee bit of common sense would kind of like explain that to you. Maximum is high, minimum is low. All right, so we need to remember these graphs and be able to draw them really quickly. Then you've got the tan graph. So just a quick reminder, because I do have one wee sneaky question about the tan graph in here. Tan graph is slightly different. It doesn't have a maximum or minimum number. It just keeps going up and it keeps going down and it never ever quite reaches 90. So tan of 90 is undefined, tan of 270 is undefined. Check that in your calculator, it will come up error. Now the period of the tan graph is not 360. So tan graph's out on its own. Its period is 180. And remember, that's because it starts to repeat the same diagram at 180. This side, the right-hand side, is the exact same as that left-hand side. So effectively, the tan graph is just this bit on the left here. And it starts to repeat at 180. But we always draw them between 0 and 360. So let's look at some questions. So we have sometimes in a non-calculator question expected to be able to write down the values of something without a calculator. So the first one I want to do is 3 sine 180. So I'm going to quickly draw a wee sketch of my sine graph, because without the sine graph I'm not 100% sure what it is. I can picture it in my head, but for pupils I always get them to draw it. So remember, there's your sine graph. There's 360. So 180 is in the middle. Now at 180 that is 0. Okay, so the y coordinate part of that would be 0. So 3 sine 180 is just 3 times 0, which is 0. All right. The second one, 2 sine 90. Well, there's... So sine 90 would normally be 1, but this is a 2 sine 90 graph. So it's 2 times 1, or if it's a 2 sine 90 graph, remember that goes from 2 to -2. So the highest point would be 2. Either way, it's 2 times 1, it's 2. Okay. And my third one, to do 5 cos 360, I'm going to draw a quick sketch of my cos graph. Remember, it's a hammock shape. 360 is here. So 360 is the highest number it goes to, which is normally 1. So this one is 5 times 1. Or if you were sketching the graph, you would say it goes from 5 to -5. So the highest point is 5. So they all come from your knowledge of the graphs. Question 2 is similar to question 1, but this time they're asking for not the value of it, they're asking for the turning point. So in my previous questions, I could have written each of them as turning points, but in this one, it's specifically asking for the minimum turning point of each one. So the graph of 4 sine x, so I'm going to do a wee sketch. So the graph of 4 sine x looks like this. Its maximum is 4 and its minimum is -4. So the lowest point it goes to is -4, and that occurs, remember the middle is 180, So the middle of 180 and 360 is 270. So as a coordinate, that would be along 270, down 4. For part B, the minimum turning point of this one. So this is a cost graph that has been moved. So remember, plus 30 means the graph has actually moved 30 in the negative direction. So I'm just going to work on the cost graph just now, and then we'll worry about what the movement is. So your cost graph, the minimum turning point of a 2 cost graph would be at -2. Now this would normally be right in the middle, it would be 180. But remember, we've said we've moved that back 30 in the negative direction. So if you do 180 and move it back 30, that gives you 150. So our turning point here will be along to 150, and it will still be down 2 for the minimum turning point. And then my last one, y equals 3 sine x minus 2. Well, your 3 sine x graph looked like this. And it went from 3 to -3. Your minimum turning point was here. So middle was 180. So that was another 271. So it's along to 270. And it would have been down to -3. But remember, this -2 tells us we've moved this graph down 2. So -3 moved down 2 would take you to -5. Now these might look horrendous, but if you know your graphs, they're really not, okay? So they were quite similar, those two questions. Right, question 3 is a bit trickier. So given that sine 30 equals 0.5, we have to write down these other values. Now, sine 30, what that means is, remember you've got your trig equations, and you would have sine x equals 0.5. And then you would do x equals inverse sine of 0.5, and you would get your answer out. You would get the acute angle out. Now, they've told you what the answer was here, right? So they're basically telling you that your acute angle was 30. So they want to know what sine 150, 210 and 330 is. And I'm going to do it 2 ways. First of all, I'm just going to do it by talking about your all sine tan cos table. So your acute angle was 30. They then ask you to do sine of 150. Now sine of 150, do you notice that that is just 180 take away 30? So that's your second answer if you were using the sine box. And sine is positive in that box. So the answer is just the same. So sine 0.5. So sine of 150 is also 0.5. Now the 210 falls in your tan box. And the connection there is that's 30 added on to 180. Now if you're solving a sine equation and your answer's in the tan box, that meant that the bit we were solving here was actually negative 0.5. So what they've done is they've done 180 plus 30 to get 210. So sine must have been negative. So that's us solving negative 0.5. And then sine 330, if you look at this in the cost box, there's 330. That's just taking 30 away from 360. So they've been solving a sine equation in the cost box, so it must have been negative 0.5. Now I said I was going to show you it 2 ways. I can also kind of do this from the graph. So let me clear this a minute. So from my sine graph, if I draw it out, there is your sine graph. Your 0, 180, 360. Now they've said that sine of 30 is a half. So here is the line of 0.5. There is 30. Alright. Now your 150, I can't draw it in very well. Your 150 would have been here. And using symmetry, that's 30 away from 0. That's 30 away from 150. They're in the same point. So that's why sine 150 and sine 30 have the same answer. Now your 210 would be here, and your 330 would be here. So they've both got the same answer. And then just knowing that that is 30 onto the 180 and 30 away from the 360 kind of helps you think, well, this is us just using the negative parts. So we're using the sine and the tan parts, and it would be the exact same. because all the numbers I gave you are 30 away from all our points using the all sine tan cos box, they all have effectively the same answer. You just have to decide whether it's 0.5 or negative 0.5. So the end two are negative 0.5. And they've asked that quite a few times, but using cos of 60 and asked you to write down cos of 240. So it's a similar wee step. Question 4, they quite often like to throw in a wee 1 mark question about what is the period of a graph without a graph being drawn. So this is testing you know what these numbers mean in your equation. So remember, the period always comes from this number. That 3 means you have got 3 waves. So to get the period, you do 360 divided by 3. So the period of this first graph is 120 degrees. So it would repeat every 120 degrees. This one has 6 waves. So you do 360 divided by 6, which is 60. So that one would repeat every 60 degrees. And then the last one, we're looking at the 3. So tan 3x, now this is a bit tricky. Remember the normal period of your tan graph, right? So the tan graph is normally got a period of 180. So in this one, it's not 360 divided by 3, it's 180 divided by 3. So that gives you 60. So that would have repeated 3 times within the 0 and 180. Maybe a tan graph is a law unto itself. Right, question 5. I really like these ones. These have been asked a few times with sine and cos, and they ask you to put them in order from small to big. Now, you don't have a calculator, so you have to think of your cos graph. So I'm going to draw it again. So it's a nice hammock shape, the cosy hammock. So there's 0, there's 90, there's your 180, there's your 270, and here is your 360. So we're not actually looking for actual numbers here, we're looking for what's small to big. And think back to very basics. When you start to learn negative numbers, we put them in order from small to big. We're going to do the same here. So cos 90, if I change my colour pen so you can see this. Right, there's cos 90, that's 0. Cos 200 is, it's somewhere in here, right? So that is pretty negative. Cos 360 is here, which is just going to be 1. Remember, your graph goes from 1 to -1. And then cos 80 is going to be here, which is positive, but it's not as big as the number 1, is it? So it's positive, but it's less than 1. So in order from small to big, the smallest one is your negative. So in order, we have cos 200 is the smallest. Then 0 from the cos 90 is the next smallest. The 81 was a lot lower than the 361, so it's cos 80. And then the 361 was the biggest. So that's what we have here. Okay, so hopefully this is just taking you through some of the wee sneaky questions worth 1 or 2 marks, which we generally don't teach towards, but when you come to do past papers, they always cause a wee bit of bother, so it's worth maybe just having a wee try at some of these. Thanks very much.